My name is Bogdan Popa, and today I will be talking about GUI Easy, a library for declaratively building graphical user interfaces in Racket. Racket comes with Racket GUI as part of its main distribution. Racket GUI is a cross-platform toolkit for building graphical user interfaces. It's powerful and flexible, having been used to build the Dr. Racket IDE, and part of that power and flexibility comes from the fact that it's built on top of the Racket class library. Unfortunately, that also means that the API that is exposed to the user by Racket GUI is fairly imperative. In addition, Racket GUI is unopinionated concerning state management. So it's up to you to figure out how you're going to keep track of state in your application, and more importantly, how you're going to synchronize that state with your user interface. GUI Easy is my attempt at adding a declarative layer on top of Racket GUI, and I believe it achieves this in two ways. First, by hiding away the details of the class system and providing just regular functions for the user to use to construct the view hierarchy. And secondly, by providing an abstraction for keeping track of state within an application and automatically propagating state changes to the views that depend on those particular bits of state. This also means it's less flexible than Racket GUI. In particular, you cannot opt out of the state management abstraction. Here we have an example application built with Racket GUI on the left and GUI Easy on the right. I can run both of these and I get roughly the same result. So it's just an application where you can increment and decrement the counter. In the Racket GUI version, you can see that every widget is sort of imperatively constructed. So we create a new frame, then we create a horizontal panel, then we pass the frame as the panel's parent, then we create the three widgets within the panel, and in these cases as well, we pass the panel as the parent of the button, the message, and the other button. In contrast, in the GUI Easy version, the source code more closely corresponds to the final layout of the application. So we have a window with a panel inside of it with three other views inside of it. Then when it comes to state management, the Racket GUI implementation uses a mutable variable to keep track of the current count, and it has a function that is in charge of changing that count. And then an additional sort of responsibility of that function is to propagate every change to the count to the text field or the message field that depends on the counter. In the GUI Easy version, we wrap the counter in an observable value, and then GUI Easy knows how to propagate changes to that value up to the views that depend on it, in this case, the text view. So when the button's callback runs and changes the count, the text view is automatically updated with that new count, and we don't have to do anything ourselves. So the basic building blocks provided by GUI Easy are views, and views are just regular Racket functions that combine to form the GUI hierarchy, and they know how to respond to changes in the observables that they depend on. So, for example, a text view depends on its input message and changes the label whenever that message changes. A choice view may change the selection whenever its selection input changes. A canvas view will apply its painting function every time its input data changes. And then observables are like boxes that have the ability to broadcast changes in their values to observer functions. So we can define an observable and then subscribe a couple functions to it, and then push a change to that observable. And when we do, both of those functions trigger. And in this case, both of those functions just print the new value of the counter to standard out. Observables can be mapped. So we can take that previously defined count observable, apply a function to it, or map it using a function. In this case, we're just squaring the value, and then just like with regular observables, we can subscribe functions to these ones as well. And now when we push a change to the original count, both of its original observers trigger, as well as this new one that we've subscribed to a derived observable or a mapped observable. However, derived observables cannot be updated. And so if you try to update the count squares observable, that leads to a contract violation. Sometimes you might have to drop down and implement custom views, perhaps to wrap a new widget in the GUI library or a custom one that you've developed. And this is fairly straightforward. Every view must implement the view interface, which is made up of 4 methods. Every view needs to be able to list the observables that it depends on. And that could be an empty list, in which case it'll be a completely static view. And then when it's first displayed, it needs to be able to create the underlying widget, the underlying Racket GUI widget. And then it needs to know how to respond to changes in its observables. And finally, it has the ability to perform any sort of teardown actions when it's no longer being displayed. And so the life cycle looks something like this. First, its parent will ask for its dependencies. Then its parent will ask it to create the underlying widget. Then its parent will send it any changes in those dependencies while it's being displayed. And then finally, when it's no longer going to be displayed, its destroy method will be called. Here's an example custom view, which is just like the built-in text view. It has a single initialization field, which is an observable of a message. It then lists that observable as a dependency, and when it creates the widget, it instantiates a Racket GUI message class and gives it the current value at the time of the message observable as its initial label. And then finally, whenever the message is updated, it propagates that update to the underlying widget by changing its label. And there's no teardown that it needs to do, and so its destroy method is a no-op. Finally, we wrap, to hide the details of the class system, we wrap the instantiation of these custom classes in a function, and then we can use those functions just like we would any of the built-in views from GUI Easy. Next, I'm going to demo building a simple application just to show you what it feels like to use the library in practice. For this portion of my talk, I'm going to make a small front end for a debugging library that I've been working on. So I'm going to use lang Racket base. I'm going to require the client portion of that library. The details of the debugging library aren't very important. It's just it has a client server model, and I've got a client running in the background, so we can test the UI against it. I'm going to require Racket GUI Easy. I'm also going to require Racket format because I know I'm going to need it. And to begin with, I'm going to define a function to run the UI. For now, it's not going to do anything. And I'm also going to define a test submodule to run the GUI with a connected client. And the reason I do this is because Racket mode for Emacs makes it easy for me to run my test submodule just by hitting a key binding. So now if I change this to render a window, maybe whose title is remote debugger, and maybe the window contains some text that says hello world. And now I run my tests, I get a little GUI. All right, and maybe let's also make that window a little bigger by default. So 400 by 300 pixels. There we go. And now I can use the client to get some general metadata about the server. And now let's try to display some of that metadata. Maybe we want to display the operating system. And that that works, but obviously that doesn't look great. So let's nest these two inside of a H panel. And that's better. And now maybe let's also display the Racket VM and the Racket version. There we go. Obviously this isn't ideal. We'd want to get rid of the spacing here and also align the values vertically. So let's introduce a helper function called labeled. It's going to take a string label and some arbitrary view. It's going to nest them inside an H panel. And for the text, it's going to nest it inside of an H panel with a minimum size, where let's say the width is 100 pixels and the height can be anything it needs to be. The nested H panel is also not going to stretch horizontally. And now let's convert these. Cool. Now we still have the spacing problem, so we have to convert it to tell the outer H panel not to stretch vertically. Whoops. So we want it to stretch horizontally, but not vertically. Cool, that was good so far. And now let's extract the info bits into their own little view. Nest them inside a vertical panel. So, whoops, I called this get info. I should have called it info tab. All right, now we can get rid of that. And our GUI is the same. And the reason I did that is because I want to introduce another built-in view called tabs. And what tabs does is it, displays a tab view. And the first argument of the tabs view is the list of tabs. In our case, that's going to be info and memory. And then the second argument is an action function to run whenever a tab is selected or whenever they're reorganized. And that takes an event, a list of choices, and the current selection within the list of choices. So when the event is select, for now we're just going to print the choices and the selection. And then the final argument is going to be the contents of the tab, the tab view. And so in this case, even though we're now selecting a different tab, because our contents are static, they don't change. But as you can see here, the action does fire and our sort of printf expression runs. And so now what we can do is we can introduce a current tab observable, and by default it's going to be info. And when a new tab is selected, we can update that tab observable and set its value to the current choice. All right, and then for the contents of the tab view, we can use a case view to dispatch on the value of the tab. And so when the tab is info, we display the info tab. When it's memory, we display, well, for now, let's just display the text memory. And then we also need a fallback, even though for us, this is not going to be reachable. So we'll just maybe add the text unreachable here. Okay, and now we can switch between tabs. And let's add a view for the memory tab. It's also going to take a client, text. All right, so our view looks the same still. And for the memory tab, let's get the total memory use and wrap it in an observable. So get memory use from the client. And then let's also get the total object counts from the client. And then for the memory use, let's use our labeled helper from before and display the total as text. Okay, so that works. The total is in bytes, so maybe let's add a little helper function here to convert the bytes to megabytes. So divide the bytes and then convert to a string. All right, now we have the total in megabytes. And for the counts, we're going to want to use a table view. And so let's introduce a vertical panel here and use a table view. So the table view takes as its first argument a list of column names. So our first column name is going to be kind, our second one is going to be count, and then size. And then its second argument is the data as a vector, or an observable of a vector. So we're going to take our counts, which is an observable of a list, and then convert it to a vector. And we can provide it with a way to, given an entry in the vector of rows, give it a function to map that entry to a vector of columns. And so we just take the entry and grab its car, which is the kind as a string, the kind of object, and then the catter of the entry, which is its count, and then the cadutter of the entry, which is the size in megabytes. So I'm going to use my little megabyte helper there. And there you have it. We have a little table with object counts and total size. And now to make this view a little bit more dynamic, I'm going to introduce a button that's going to say like reload, and then when we hit that button, we're going to update the total and just assign the current memory use to it, and the same thing for the counts. Get object counts. Okay, so now I can come here and reload my data. Let's get rid of the spacing there. So it's going to stretch horizontally but not vertically. And yeah, there we have it. Hopefully this gives you a taste of just how easy and natural it is to put together these GUIs using GUI Easy. Thank you for attending my talk. The library and its documentation are available on the package server, and you can find the source code on my website at defen.io. Alongside the source code, you'll find several example applications, so I encourage you to check those out if GUI Easy appeals to you. Thanks.
Excellent, Bogdan. Hey, so let's do questions now. So first question is, okay. So there are a few technical questions, and there are a few kind of broader ones. So as like a broader one, you showed how to GUI Easy allows you to do something to build a GUI in this like declarative way. And it feels extremely close to be able to building something that is like almost a no coding tool at all, where you can have like a user interface designer use something that is a GUI easy based DSL to build like an interactive prototype and an interactive program. And what are your thoughts about that? And do you think that is that something you're interested in? Do you think that's feasible for building something real with almost being able to ignore like the technical details of observables?
Mm-hmm. I think you could definitely hide some of these aspects away further. I think that's not really my goal here. My goal, like the intended audience of GUI Easy is someone who's a programmer, right? And it's me basically. But yeah, you could definitely take this further and maybe even go in some sort of an HTML type of direction, right? You'd lose some power presumably by going there, but you could do it. And then prototyping by a UX person could be feasible, but that's not the direction I'm aiming for.
Cool. Okay. Now, you showed how a custom view has to obey this like particular interface, and the way that I kind of think about that is that basically that custom interface of view is like that structure is really the thing that you're providing. Like you came up with that that abstraction, and then you went and implemented that for each one of the different things that are part of the Racket GUI system. And people are curious about like, what can that not expose? So for example, could that expose, I don't know, the window context for doing OpenGL and Vulkan stuff? Or would that be something that is too deep to expose? Like, when you designed that abstraction, did you have in mind things that you didn't want to, that you wanted to completely hide and be inaccessible? Or what are your thoughts about that?
I think that abstraction allows you to do, if you dive down to the level of custom views, then you can do pretty much anything that Racket GUI lets you do. And so you could definitely create a custom window view that exposes that GL context. And in fact, the window view provided by GUI Easy actually lets you hook in a mixin to wrap the window object. And so you could do it that way. And then there's also just specifically for canvases, there is a canvas widget that already gives you a drawing context that you can use. And so you don't even need to do all of this because the library provides it for you. But yes, to answer the original question, you can definitely dive down to that level. And the abstraction will mostly let you do, I think, pretty much anything that Racket GUI would.
That's cool. Okay. Now, I think someone is asking a question about like what kind of widgets are available. So they say, can you partition all available space into a grid and then assign widgets within areas of the grid? So I imagine when they say grid, they mean like, I feel like normally when you think about GUIs, you often think about them in terms of, well, there's a horizontal stacking part and then a vertical stacking part, and you kind of like interleave those. But you have a widget that basically just says, I want to divide up the screen into a 3x3 grid or something like that.
No, but you can achieve that by combining the horizontal and vertical panel views.
Mm-hmm. And you could presumably use that to like build an abstraction that simulates, for instance, like the CSS grid model. And exactly. It's plausible to me, at least, that it would be easier to build that abstraction targeting GUI Easy than it would be to think about it targeting Racket GUI itself, just because there's so much, boilerplate that you're hiding.
Yeah, I think so too.
Cool. Okay. Now here's like a really specific question. Is the result of case view different than a map obs result?
Yes. So case view returns a view. Okay. It itself is a view that knows how to change its children as its input changes, whereas obs map would return an observable. And so you would get a contract error in that position because an observable is not a view.
So basically like the case view, in the model view controller way of thinking about things, the case view is the view and the observables, they're the model. And so they just don't connect one another. So even though you might think of it as, oh, it's one of those, it's something with a function attached to it. It's a different kind of thing with a function.
Mm-hmm. Yes, exactly.
Okay, cool. Okay. There's this cool benchmarking tool. When I say benchmarking, I don't mean like performance, but benchmarking in terms of like expressiveness. That's called 7GUI, where 7GUI is like a list of tasks where you should try to do these tasks to show how your GUI is really awesome. Are you familiar with this, and have you done the 7GUI tasks in GUI Easy?
I'm aware of it, and the repo for GUI Easy has an examples directory. I don't think it has all of the 7 GUIs, but it has some of them at least. But as far as I remember, it should be able to do all of them without issue.
That's cool. Cool. Now, that view infrastructure that you came up with, and the concept of an observable, I mean, you're using them for GUIs, but they're really just a general sort of flow-oriented programming idea. And, you know, sort of, A, do you see value in using them outside of GUI Easy? And B, like maybe there's something that you know about how the implementation works where you're like, yeah, you might think that it would work, but actually there's this really GUI specific thing that's hidden there that you might not pick up. What's your take on that?
There's nothing GUI specific about them, so they could definitely be reused. As far as using them outside of GUI Easy, I haven't really thought of use cases, but they are sort of, yeah, you could totally use them and be fine.
Do you think that you could take a GUI Easy program and just sort of change something underneath the covers, and then now it is a glorious terminal application? Because there are some people who know that windowing toolkits are lame and that pixels and colors, I mean, these are for the weak. That true people, they use only text terminals all the time. And so, but I really like how GUI Easy looks, but I want to do it for a real GUI, i.e. a real user interface with only text characters.
The way the library is implemented right now, you couldn't, because the interface specifies that you have to create real Racket GUI widgets. But obviously that could be abstracted away and you can provide, generalize over that.
But you're not sold on this.
No, not really.
Now, what about targeting web? I feel like this feels very similar to me to like the React model of web applications. Were you inspired by that? What do you think about that?
Yeah, React was definitely an inspiration, although the model is slightly different here. This is still a retained model. We're just putting a declarative layer on top. We're not re-rendering the whole world with every sort of iteration like React, or a diff of the whole world. But yeah, I feel like for the web, there's tons of solutions. I feel like this is specifically for desktop GUIs, and that's what it's intended to be. And I wouldn't want to go to a lowest common denominator sort of thing. And I would rather just it be a really good solution for developing GUIs. And
I buy that. Okay, now the custom view % thing, that kind of tells you how to embed an existing Racket GUI thing inside of GUI Easy. What if we go the other direction? If I already have a GUI application and I want to rewrite a portion of it to use GUI Easy, is this feasible, or is it not going to work?
It's feasible at the window or dialog level. So whenever you spawn a new window, you could, in an existing Racket GUI application, just call render with your parent window as the input to that render function. You can actually pass a parent, and then everything would be taken care for you. So you could combine the two, but it has to be at that level. You can't go lower than that.
And like, what's the technical reason why you couldn't go lower than that?
It's because at that level is where all of the dependency tracking happens. So it's just an arbitrary point that I chose. It is possible that I could come up with a way to let you nest these things at the widget level, or widgets other than Windows, but yeah, it's just not something I've worked on. Yeah.
So maybe to understand that, help me understand that, there has to be a place where, as you said, we actually do the dependency management, and exactly. You did that in the window. You could
yes, I did that in the render function. So something you call render and you pass it a window view, and then that takes care of everything. But yes, there has to be a point where we collect all the dependencies and then figure out where to send any changes.
Yeah, and so you could imagine, for instance, that your library would like create a thread on the side, and that thread on the side would be like the one place where all the dependency management was happening, and it would like talk out to this window or to that widget or to whatnot. But you've found that it's been more convenient to stick that in the window, and that limits how the composition can happen.
Yes. Yeah. Because composition with that just wasn't something I was thinking about. But if people start using this and then they feel like that's a good use case to support, then I feel like I would definitely want to support that.
Cool. Awesome. All right. So that's all the questions. This is really cool. And thank you so much. See you later, Bogdan.
Bye.